How do we know if something is a parallelogram? If we've got a four-sided shape, we know it's a quadrilateral, but how do we know it's a parallelogram? Well, we've investigated some ways, and so far we know that if the opposite sides are parallel, that's good enough because that's just the definition. All right, so if we know these sides are parallel and these sides are parallel, well, of course it's a parallelogram, right? So that's the first reason. Okay. What if we know that the opposite sides are congruent? Well, if the opposite sides are congruent, that is enough to know it is a parallelogram. Okay. And what about the angles? So if we got those opposite angles, if they're congruent, well, we've proven, we made some triangles out of it, and if we know that the opposite angles are congruent, that means it has to be a parallelogram. Okay. And what if the consecutive angles are supplementary? So we've got these consecutive angles. Maybe we know that there are 100 degrees and 80 degrees. Then that would be enough to say that this is a parallelogram. All right, so, and then we've got the diagonals. If we want to prove that this is a parallelogram, we could prove that the diagonals bisect each other. That would be good enough to say that it's a parallelogram. And last but not least, we've got kind of this unique one. If we have a quadrilateral, and we know one of the sides is parallel to itself, we don't know the other side, and we also know that these two sides are congruent. So I said that backwards, kind of. They're congruent and they're parallel. That would be enough to say that it's a parallelogram. So if one pair of sides is parallel and congruent, that would be good enough. So we have our definition, which obviously makes something a parallelogram, and 5 different ways that we can prove that something is a parallelogram. All right? So really 6 different ways total. So let's try this out with a problem. We're going to go to an example, the last example in our notes there, and see how we can prove these things in the coordinate plane. So let's try that out. So here we go. We have a quadrilateral. It's in the coordinate plane, and we want to prove that this is a parallelogram. Now, when we're doing problems like this, we really only need to prove it one way, but we're going to do this several ways, all right? So let's start out by getting parallel sides. So what do we know about parallel sides in the coordinate plane? Well, parallel lines have the same slope. So if you want to show that something's parallel, we've got to find some slopes. So let's go find some slopes for these different sides. So I'm just going to list my sides here, and then we'll find some things out about them. All right, so for AB, what's the slope? This guy right here looks like we're going up 2 over 5. So that is a slope of 2/5. What about BC? Well, we're going down 3 over 3. So that's going to give us our slopes. We can find all of our different slopes here. We've got -3 over 3, -3 over 3, 2/5 and 2/5. And these opposite sides are the same slope, so they're parallel. That means it's a parallelogram. All right. So we've proven parallel sides. Great. Now, let's go ahead and investigate the lengths of the sides. Ooh, how about that? So let's go for side lengths. Well, how do we find side lengths? Well, if it's a horizontal line, we can just count. But these lines are all diagonal. Okay, so we've got to use Pythagorean theorem. So we're going to look at each of these sides, and we'll find their lengths. Okay, so we've got AD, and we've got AB, and we've got CB, or BC, and DC, or CD. Okay, so let's go find some lengths. Starting with AD, well, we're going down 3, right 3. So we need to use the Pythagorean theorem. Even though the slope's -1 here on this right here, we're going to use Pythagorean theorem. 3 squared plus 3 squared equals c squared. So I'm going to come off to the side here, and let's make some Pythagorean theorem. 3 squared plus 3 squared equals c squared. Well, that's 9 and 9, that's 18. And then we've got to square root both sides. And so we're going to get the square root of 18. Okay, now notice this guy here on the other side is also over 3 down 3. So if we make this triangle here, then we use the same Pythagorean theorem. We don't need to write it out again. I think we can just say that that is the square root of 18. Now these guys over here, we're going up 2 over 5. So I'm going to have to compute that one. 2 squared plus 5 squared equals c squared. That's going to be 4 and 25. This is 29 square root. And so this is the square root of 29. This guy over here is also going to be over 2 over 5 up 2. So that's the square root of 29. So we just proven that opposite sides are congruent. So it's a parallelogram. Okay, so let's jot that down. So we're saying that opposite sides congruent. So that means it's a parallelogram. Yay, we've proven it. All right. So we can find the slopes and find that they're parallel, or we can find the lengths. What else would make these parallel? Well, the angles would, but we can't really find much about the angles. So there's one more way to prove that this is a parallelogram, and that's with the diagonals. So we're going to look at the diagonals here. And what do we know about the diagonals? We know that if they bisect each other, it's a parallelogram. So we've got to figure out if they bisect each other. So I wonder where the midpoint is for AC. So we've got to find the midpoint for AC first. And then we'll find the midpoint the other way. Okay, so if we look at AC, the midpoint, remember for the midpoint, we average the x's and average the y's. So we're going to look at those coordinates. The x's are -3 and 5. Okay, so let's average those x's. So we're going to go -3 plus 5 divided by 2. The y's are 3 and 2. 3 and 2, so let's average those. 3 plus 2 divided by 2. Okay, and so this is really kind of two formulas in one. So if we average those, the midpoint we get, this is 2 over 2. And this is 5 over 2. Or 1 and 2.5. All right, so there's the midpoint going one way. So now we got to go the other way. Let's look at these 2 points. Let's look at D, which is at 0, 0, and B, which is at 2, 5. Where's the midpoint going this way? I'm hoping it's the same thing. So from D to B, let's find the midpoint there. So D, B, the midpoint, let me write those down. Let's see. They were 0, 0, and 2, 5. Those were the coordinates. We can look back there. So our midpoint is going to be, add the x's, and divide by 2, add the y's, and divide by 2, and we get 1, 2 over 2, which is 1, and we get 5 halves. Well, that's the same thing, right? We have, that is 1 and 2.5. Okay, so these midpoints are the same, right? Same midpoint. In other words, they bisect each other. So we can say yes. We can say Diagonals bisect each other because they go through the same midpoint. Okay, they have the same midpoint. And so it's a parallelogram. Diagonals bisect each other. So it's a parallelogram. That's the idea. Okay, so these are the ways to prove that it's a parallelogram. Okay, we got to show one of those things. Okay, and parallel sides or side lengths or diagonals to see that it's a parallelogram. So, all right, go for it. Try it out. Work on that assignment and use those coordinate proofs.